pale point of light is moving across the night sky right now, and on April 27th it will be closer to Earth than it has been in over 4,000 years. Astronomers have been tracking it for months. They've measured its speed, mapped its path, calculated exactly when it will pass us. And yet there is one thing about this comet that none of them can explain, because every time they point a telescope at it, it looks slightly different than it did the night before. We've named it, cataloged it, fit it neatly into our charts, but comets are supposed to behave. They follow the rules. They swing in from the dark edges of the solar system, loop around the sun, and fall back into the black on a schedule we can predict centuries in advance. This one is doing something else, and the closer it gets, the stranger it becomes. Here's what we know for certain: it's old. Spectral analysis of the dust streaming off its surface suggests this object formed in the outer reaches of the solar system, in a frozen region we've barely begun to study, a place where the sun is just another star, dim and distant, offering no warmth at all. Out there, this comet sat untouched for billions of years. A time capsule of ice and rock from the moment the planets were still forming. Whatever it's made of, it's older than every fossil on Earth, older than the oceans, older than the moon's oldest craters, and now it's coming to visit. When a comet approaches the sun, it warms up and the ice locked inside it begins to turn to gas. That gas erupts off the surface in jets, forming the glowing halo and the long sweeping tail we associate with comets. That part is normal. That part we understand. But this comet has been brightening in pulses, sudden flares, where it leaps to several times its expected glow in a matter of hours, then dims again. Astronomers call these outbursts. What they don't fully agree on is what causes them. Some say pockets of exotic ice, frozen gases that explode the instant sunlight touches them. Others think the comet is cracking apart, splitting along ancient fault lines, exposing fresh material with every fracture. There's a darker possibility, too, that the outbursts aren't random at all, that something inside this object is venting in a pattern, and we simply haven't watched it long enough to see the rhythm. Then there's the matter of its path. Comets are pulled and nudged by the gravity of everything they pass, planets, the sun, even the faint tug of other comets. Their trajectories are complicated, but in principle completely predictable. We run the numbers and the comet goes where the numbers say, except this one keeps drifting off course, just slightly. A few kilometers here, a few there, not enough to threaten us, but enough that the people tracking it have to keep recalculating. The gas jetting off its surface acts like tiny thrusters, pushing it in unexpected directions. It's a known effect. It even has a name, non-gravitational acceleration. But knowing the name doesn't tell you where the comet will be next month. It only tells you that the comet is, in a very real sense, steering itself. Think about that. An object older than our planet falling toward us through the dark, gently changing its own course as it comes. On April 27th, at its closest approach, it will still be millions of kilometers away, far beyond the moon, posing no danger to anyone. You may not even be able to see it without a telescope or a good pair of binoculars and a sky free of city lights. But it will be there. A faint smudge of light that traveled from the frozen edge of everything, that waded through the entire history of life on Earth, that will pass us once and then vanish back into the dark, possibly never to return in any time frame that means anything to our species. And this is the part that stays with me. We will watch it go. We'll photograph it, study its tail, publish our papers, and then it will be gone, carrying with it whatever secrets are locked in that ancient ice. The next time it comes around, if it ever does, there will be no one alive who remembers this night. No telescopes that exist today. Maybe no one at all. Every comet like this is a messenger from a time before us and a reminder of a time after us. It doesn't care that we named it. It doesn't know we're watching. It's simply doing what it has done for 4.5 billion years. Falling, glowing, drifting, keeping its own quiet schedule across distances we can barely imagine. So when the night of April 27th comes, and that pale light slides past us and begins its long journey back into the black, ask yourself this. If an object that old, that patient, that far from home can still surprise the smartest people on Earth every single night, then how much of what's out there have we actually understood, and how much are we only pretending to know?